Alright, so we're going to start in 6-7, and this is basically just working with your critical values. It'll also have you working just with finding probabilities given a normal distribution. So here we go. Alright, if NP is greater than 5 and NQ is greater than 5 or equal to 5 for either of them, then estimate the probability of fewer than 7 with n is 14, p is 0.5 by using the normal distribution as an approximation to the binomial distribution. If NP is less than 5 or NQ is less than 5, then just state that it's not suitable. So basically it's saying we have to check NP and NQ first. So literally you can just do NP, so n, which is 14, times p, which is 0.5, and make sure that it's greater than 5. It is. So then we have to do q, which q is just 1 minus p, so 1 minus p, and I'm just going to put it in the same thing. We're still greater than 5, so it's still fine. So I'm going to go ahead and say that's checked off our list, and now I don't need to worry about it. So I'm going to go ahead and put this in here. So go ahead and set up this table. So pause the video right now, set up the table, and then come back. Sorry, this is cut off a little bit, but go ahead and pause. Alright, so now that we're back, we're going to go ahead and put in these numbers. These numbers that I have in here right now is just testing to make sure the table works, so it doesn't really matter. So what do you think is going to go in n? The number that's equal to n. So we're going to type in 14. Then we're going to do p. So p is given to us again. It's 0.5. Q, I have it written right there. It's equal to 1 minus p. I'm just going to highlight my p box and hit enter. I've been doing these videos on an iPad, but I found a way to do them on my laptop, so now you can see some of the different functions that I've been referring to when I do it on the iPad. So then it's saying fewer than 7. P fewer than 7. So we want our x to be 7. Does that make sense? Great. So now we're going to have it as equal to 7. Our next step is going to do our mean. So our mean is n times p. So we're going to do equals the mean. So our mean is equal n times p. If you want to use product, you can. Then we're going to do the standard deviation. The standard deviation is equal to the square root, so square root of n times p times q. If you want to do sorry, we have breaking news on the hurricane. We're going to do equals n times p times q and the square root of it. If you want to use product, again, you can use that. It's just fine. What I am going to do, though, because Pearson's a little bit finicky, is I'm going to round, and I'm going to round this to 2 decimal places. If you need to round it to 3, you can do that as well. Just use 3 instead of 2 there. So then we're going to do our z. Our z is equal to our x minus the mean. So x minus mean, which we found here, divided by the standard deviation, which is right here. Hit enter. Okay, so it's 0. So here's the thing, is when we do this, you have to do plus or minus 0.5. I forgot to say that on purpose because I wanted you to see that you're going to get 0. So because we want fewer than 7, we're going to go less than 7 because we don't want to include 7. So we're going to do 6.5. And now we'll have a number. Again, I'm going to round this number to 2 because Pearson is a little finicky. Alright, so because we want, I'm going to have you set up your table so that it's all of these different things, but I just wanted to start with this because it made a little bit more sense. So the first thing we're going to do is do the exactly. So if we have exactly a certain amount, then we're actually going to have to do a little bit over and a little bit above. So there's this joke in math where it's like 3 statisticians go hunting, and the first one misses a little bit to the right, and the second one misses the deer a little bit to the left, and the third one says, "Oh, we got him!" And it's because when we're looking for an exact value, we have to go 0.5 above and we have to go 0.5 below. So in that case, it's actually going to be kind of sad, but we're going to have to do a little bit more work. So you're going to actually have an x value in this square as well. So I'm just going to say, since we're doing 7 right now, I'm going to do 7.5 just to give you the example. The mean and the standard deviation are going to stay the same because nothing with x is involved in those. Your z-score will change though, and I'm going to use the round function still. So x minus your mean divided by the standard deviation, comma 2 because I'm rounding to 2. So same as before, and because this is exactly 7, just the way this problem works out, you will get a probability of 0 here. But your probability is going to be equal. And remember how I said before, we're always calculating from the left to the right. So we're taking our higher one, which is going to be 7.5, so our higher z-score, minus the lower z-score. Same as before, we're not changing anything. It's the same idea. Sorry, I'm clicking things and make sure I've typed in the right function and adding stuff over there. Give me just a sec. So we're going to use equals norm.s.dist. We're going to do the higher, comma true, minus the lower, comma true. And I'm just using 1 for true. You can type in true as well. It'll still work. Something screwed up. Oh, I forgot to T. There we go. So it will give you something for this one because you have, these are different. If I was just subtracting them, they would be the same. They would give you 0. Anyways, so moving on. If we want more than, remember we're always calculating left to right, so we're going to do equals 1 minus norm.s.dist of our z-score. We're going to use the top one from now on. The only time it matters is for that exactly. Otherwise, this doesn't matter. Z-score, comma 1. And actually, this section does not include critical values, so we don't need this for this one. Alright, you're at least. So basically it's saying the least you can go to is blank. So you're going to still be calculating something to the right, so we still need to do 1 minus. So 1 minus norm.s.dist, and do this, comma 1. Less than, so we're calculating from left to a certain point on the right, so we're looking for that left section. So this is just going to be normal, norm.s.dist. And then at most, so we're still calculating right to left, so norm, or left to right, sorry, norm.s.dist. And that value, true, enter. So some of these, they do give you the same, but I just wanted to give you the different wordings here, so that way you can kind of match them up. It's easier to do it that way. I also highlight the tiles that need to be filled in, so I'll highlight that, and if I don't have one for something, then I'll just delete it, and I don't have to worry about it. These other 2 tiles here will need to be filled in, but the nice thing is this one you only have 3 tiles that need to be filled in unless you're looking for an exact value. Alright, so I did throw in some other ones here that you can try with. I do want to do this one with you, and then maybe one more. So if, and again, it has to be greater than or equal to 5, more than 6. So we're going to test this one out, and I just want you to see this. So sometimes it does not work. So you're going to do equals 12 times p, which is 0.7, and we have 8.4, so we're still good. But what happens when we do 1 minus? Because they both have to be true. Now we're less than 5, so you can't do this problem because it's less than 5. So I'm actually going to take this back down here. This one here is the same idea as what we just did. This one, same idea again. Your x is going to be 43. Your n is 178. You just have to kind of determine like what is what. And then again, this is the same idea as well. So I'm just giving you some problems here that you can practice with rather than me going through all of them. I just wanted to give you some that you can practice with and see if you can get the right answer.